Today we're going to be talking about the table lookup method, and I've just given you the handout with the equation formulas. We'll continue talking about that a little bit. Just to remind you about the announcements, your second homework assignment is due next Wednesday, so that's a week from today, where we don't have classes on Monday the 1st due to Labor Day. So does anybody have any questions about the announcements or just anything in general from previous classes? Okay, on the subject of the homework, I've gotten some feedback from the grader that some people aren't correctly submitting the assignment. So I wanted to just review a couple of things with you. The first is that I recommend you use Adobe Scan. There are a few other scanning apps that don't have the same like image enhancement availability and features, and so Cam Scanner is also okay, but some people aren't getting quite the contrast that would be needed for the grader to be able to easily make up to make out what you've written. So just as an illustration of what I mean by contrast, these two images are the same, but the top one has poor contrast, the bottom one has good contrast. It just means that the background is easily distinguishable from your writing. So the signal to noise is like a big spread between what we want to see in the background there. So if you're not getting good contrast, that may mean that you're not using a good scanning app, or just that the image isn't well lit. So please pay attention to that. Also, your whole assignment needs to be in a single PDF file. So if it's a JPEG, starting next time, the grader won't even look at it. And if it's multiple PDF files rather than a single continuous joined PDF file, then the grader is going to start taking off points. And I mean, your scanning app should be able to build a single PDF file, or there are online tools where you can merge the PDF together if you need to do that. Grayscale is a very easy option. It's just once you create the PDF, down at the bottom of the scanning screen, there's filters, and please set it to grayscale, because that's one of the ways that you can enhance the contrast and the focus, is by not submitting the image as a color image. And then also, I mean, the engineering computation paper is a little bit more expensive than regular paper, but it's still relatively cheap. So spread out your solution, give your writing some room to breathe. Don't try to do the entire assignment on one page of paper so that then the grader needs like a microscope or something to read it. You know, just don't put too much stuff onto one page, and put a little bit of a gap between problems that you're working on, just to make it clear what your solution is. Another thing you need to do is box the final answer, because you know, obviously your solution should be linear, where you start at the top and finish at the bottom, but even still, it's really helpful if you put maybe, like for the final answer, you put it in a box, and then sometimes even drawing an arrow next to it can be a helpful addition. So make it obvious for the grader what your answer to the question is. And then if you have any problems with this, I don't expect you to necessarily figure it out on your own. If you're not really a tech type person, you can stop by my office and I'll show you how to do all of this. If it's just something you forgot about, then it'll be easy to fix. But if you're running into any recurring problems, then don't hesitate to let me know. Any questions before we move on? Okay, so with that said, we're going to talk about the factor method and the equation method. Seems like PowerPoint Online is having some buffering issues here. All I did was ask there. Okay, there we go. So here's the equations. Did anybody not get that who came in late? All right, so the way to read this is that see where it says symbol? The column that says symbol is a way that you can summarize the whole problem in a very short way. So, for example, the top row is find f given p, and then in the second field there where it says I%, what you do is you just write what the interest rate is that's defined in the problem. And then the third field where it says n, you'd say n equals 3, n equals 4, whatever the case may be for the number of periods. So that's kind of just like an expression syntax for how you can do these time value of money type problems. But then the column next to that where it says formula, you will put in the I value and put in the n value and end up with some factor. You know, maybe it's 12.182, whatever the case may be, but that factor that you calculate using the formula column is equal to the ratio of f divided by p for the first row. The second row, it is p divided by f, and so on. And so the way to like turn this into a formula, like the first row is f divided by p is 1 plus I to the power of n. So in other words, f equals p times 1 plus I to the n power. So that is the single payment compound amount row. And so, like for example, to find P given A, if you go down a couple of rows to the row that says uniform series present worth, the way to construct the formula from this page for that one is P divided by A is 1 plus I to the power of n minus 1 divided by I 1 plus I to the n power. So if you're trying to find P given a known A, then what you do is you calculate that factor, and if you want to know P, then you'd multiply that factor by the amount of A, the annual series. So you can always use these and be accurate to the nearest penny, because you can keep all the precision in your calculator that you get from those factors. Sometimes on the exam, I'll specifically tell you if I want you to do the equation method or if I want you to do the factor method. And if it doesn't mention in the problem, then you can use either the equation method or the factor method. So doing this is the equation method. The factor method is when you go to a table that's defined by the interest rate. So this is illustrating the 8% factor table. So each one of these columns is one of these formulas solved for different n values at I equals 8%. So just in these different equations, for example, this first column, f divided by p, that is this formula, the top one, f divided by p. For 8% interest, n equals 1, n equals 2, n equals 3. So they've just basically solved this equation for you, and then you get this factor, and if you wanted to know what is f for a given p, then you'd multiply the factor by p, and then that would tell you the future value of it. So for example, what this illustrates is that if you've got 8% interest, then you basically double your money after 9 years. See how it's 1.999? That means the ratio of the future amount to the present amount is almost exactly 2 after 9 years. Or going back to that, the bottom equation here, where we were finding P given A. So what if you wanted to find P given A? You'd use this present worth column. And if you had a cash flow diagram that looked like this, let me just write a cash flow diagram on the board for find P. So what if you wanted to find out how much do you have to deposit today? P is unknown, and you're going to have several withdrawals in years 1, 2, 3, and 4, and you've got some known amount. Maybe the amount is $100. You want to withdraw 4 $100 payments, and the interest rate is 8%. The way that you'd use this table is you'd say, all right, I'm going to go down here to n equals 4, and so the ratio of P to A is 3.3121. And so P the lump sum present value that's equivalent to 4 equal annual withdrawals of $100 each would be $100 multiplied by 3.3121. So that's $331.21. So you can either take a lump sum of $331.21 now, or take 4 annual payments of $100, and that's equivalent either way, economically equivalent when you've got 8% interest. Or if you wanted to make the withdrawals and you had to put the money into the bank now, then this is the amount that you'd have to put into the bank. But the point is, we can use these tables in order to really quickly avoid having to use the formulas. It's just, especially if you're doing a lot of calculations, it can save you a bit of time to use this table method. So any questions so far on the table lookup method? Okay, well, just as a review, let's think about what some of these columns would look like if you were going to draw it as a cash flow diagram. I already did the find P given A over there. But just as a reminder, what would a cash flow diagram look like if you were find P given F? So for find P given F, it could potentially look like this, where we use the dashed arrow, P is unknown, and then some lump sum future value, which is given in the future. And it's relatively simple, but it's just a single lump sum amount. And if we had, for example, different amounts, let's say we had 3 different amounts, what we would do to find out the total present value is we would take each one of these individually to year 0 and then find the combined effect of them together. So we take this little amount in year 2, take it to 0. Take the amount in year 3, take it to 0. Take this individual amount in year 4, take it to 0. We'd have to do it in 3 steps because the amounts are different. Now in contrast to that, if we wanted to, for example, find A given P, the way we've expressed that as a cash flow diagram is we've got some known lump sum, so P is given, and then the A would be dashed arrows where we have the same length for each of these dashed arrows, but we don't necessarily know how big they are or what the amount is. So this is find A given P. Now the trickiest of the ones we've learned so far are ones that are involving F and A. And the reason why it's so called tricky is that it's a little counterintuitive that the F is in the same year as the last time we see A. So for example, if we have a cash flow diagram where it's like 1, 2, 3, 4, 5, 6, 7. Okay, so let's say that we have some annual series that starts, it's year 3, 4, 5, 6, and then we want to find out what is the lump sum equivalent of that. So what is F? This is how you would write a find F given A. I'm writing this slightly to the side just to illustrate that they're separate, but it's both in year 6. So for this one, what we're saying is that the lump sum future value, the future, what we mean by that is the same year that the last annual amount occurs. So this is just showing like you can either get the annual amounts or you can get one lump sum in year 6. It might sometimes be an opposite direction kind of a situation. So if the arrow is down, then that's the kind of problem where what you're saying is you're receiving money in years 3, 4, 5, and 6, but then you have to make a single lump sum payment in year 6 to make up for it. So just from a graphical standpoint, I wanted to refresh your memory that our convention for future values in annual series is that the lump sum future value is in the last year of the annual series. Okay, so let's just take a look at a couple of illustrations having to do with these factor tables. Let's say somebody deposits $5,000 into an account, pays 8% per year. We've just looked at the 8% table. And the amount in the account after 10 years is what? So this is, P is known. We want to know F. So if we go to the table where P is known, find F. So find F given P, and the example is saying N equals 10 years. So here is the 10-year column, or 10-year row. So 2.1589 is the ratio. So if we multiply 5,000 by the factor that we look up, 2.1589, then the lump sum future value, 10,795. Now, a word about round off. You can see that this factor had 1, 2, 3, 4, 5 digits. And so that means we should write the answer to the nearest dollar. Even though in your calculator it might say some cents, those cents are not significant because we don't have that same level of precision in the factor. So 2.1589 multiplied by 5,000. My calculator actually says 10,794.50. But we rounded up to 795 because we don't know from the number of digits that are in this factor what the cents are going to be. So any questions about this first illustration? All right. So the second one, a small company wants to make a single deposit now so they can make a purchase of $50,000 5 years from now. So they want to have a lump sum withdrawal in 5 years of $50,000. So how much do they have to put into the account now if they earn 10% per year? You can sometimes just eliminate these based on what you know is reasonable. So they shouldn't have to deposit $300,000 in order to be able to withdraw $50,000 in the future. That makes no sense. And 10,000 seems like maybe a little bit too good to be true. But if we actually do the calculations here, this, if we express it as a cash flow diagram, the unknown is the present value. So we're going to deposit a certain unknown amount at 0 and then make a withdrawal in year 5 of $50,000. So find P given F. So the column that we'd use in the 8% table, find P given F, and how many years was it? Was it 5 years? Okay, so back to the table here. Find P given F, 5 years, so the factor is 0.6806. So the way we use that 10%. Sorry, I was looking on the 8% table just now. So the 10%, we have to go to the right table. The factor from the 10% table is 0.6209. So that's the discounting quantity. So it turns out that the amount you'd have to deposit is $31,045, but it's only got 4 digits. So we should actually round that to 31,050. So the answer is B, and this would need to be further rounded because of the precision of the factor that we've got. All right. So I think with those illustrations, we're ready to get started on today's in-class exercise. Let me bring that up on the screen and I'll hand it out to you. Are there any questions, by the way, before we get started on the in-class exercise? So, yeah.
On this sheet for the uniform gradient future work, what's the cross there for? There's a little.
Yeah, we're going to talk about gradients in a future class. They're a special case that we assume the end of period assumption, but then we also have to assume something else that's pretty abstract when we do gradients. So I'm going to defer to our next class when we talk about that.
All right. Feel like an acorn. Actually, it was in a bush. Yeah. I mean, it was it was like a branch that would fall off of a tree and then in a bush. I grabbed it on the way over. And it was an acorn.
You didn't eat the acorn?
Yeah.
You just got good.
You gotta cook them real,
Real.
because they have a bunch of.
So let me just give you a little bit more information about part A. See in parentheses here, that's where we are going to be saying, did you have extra paper?
Yeah, we have one extra.
So in parentheses, what I want you to say is find what given what. So, is it find A, is it find P, is it find F, whatever the case may be. So in the numerator is the unknown, in the denominator is the known. And then obviously you just set I equals 8% and then N equals the number of periods. So we're going to get in the habit of summarizing problems in this syntax in the parentheses. Okay, it's always a good idea to start by drawing a cash flow diagram when you're working on a problem. Helps you to see if you understand what's going on. So the cash flow diagram is that we have some unknown amount. We want to know the present value of the future payment. So the reason why the arrow is up is the problem doesn't say that we have to make some deposit today in order to cover a future withdrawal. But really what it's saying is if you get $50,000 7 years in the future, how much is that worth today? And so a inflow of $50,000 in the future is equal to an inflow of what today? So first things first, I wanted to point out that's why the arrow is up on this cash flow diagram. Okay, part A, summarize the problem in the form of what goes in those parentheses. So this is find P given F. And by the way, this is really important, being able to use this notation, because the problems get way more complicated than this. In a couple of days, we're going to be doing some really complicated multiple step problems, and if you can't speak the language, then none of this future stuff is going to make sense. So you have to take the time to get familiar and comfortable with what's going on inside the parentheses here. So find P given F for an interest rate of 8% and an N value of 7. So if we wanted to find the value of that factor using the equation, then P divided by F is 1 plus I to the negative N power. So if you're calculating your own factor, it's going to be 0.58349. And then this little dot, 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 the ellipsis that I include here, that just means that there's more digits in my calculator, and I kept those digits. I'm just not going to bother writing all of them on the paper. So that just means that there's like more precision built into my calculations than I'm displaying right now. That's what the dot, dot, dot means. So then if we find out what is the magnitude of P, like how much is that present value, then it's going to be the future amount of 50,000 multiplied by the factor that was calculated. And so it's $29,174.52. And it should be accurate to the nearest penny since we calculated the factor ourselves. So if you got sloppy and you wrote like 0.58, then you're not going to get this same number if you just calculated 0.58. So keep all the precision and then round off at the very end is how you do that in this class. So then lastly it said to use the table lookup. So for that, go to the 8% table, which is provided on the third page. So on the 8% table, we want to find the row that corresponds to n equals 7 for find P given F. So here it is, 0.5835. So it's the same factor as I calculated, but just not as much precision. 0.5835. It's reported only to the 4 digits. So then I need to round off my answer here, 29,180. So if you wrote like to the nearest cents on a table lookup where you didn't actually have that much precision, I might deduct half a point or something on an exam just as a reminder that you need to be mindful of the precision on problems like this. Okay, so that was problem 1. Any questions before we move on to the second problem? Okay, so the second problem was graphical. So this is find P given A. Use the table lookup method. So that means this 8% table. So go to the column that says P/A, find P given A. Now, what is N? Is N 1, 2, 3, 4, 5, 6? Because there's 6 lines on the cash flow diagram? No.
It's 3.
It's not 4. It's only the number of years where there's actually money happening in our annual series. So how many annual payments are there? There's 3 of them. So N equals 3. So go to N equals 3, the third row in the 8% column. And then we're looking for find P given A. That's the column that's called present worth. So if we use the table lookup method for that, then we find the factor is 2.5771 multiplied by the magnitude of A. So P is 32,214. So number of digits in our factor was 1, 2, 3, 4, 5. And that's the number of digits that I've included in the final answer as well. And then finally, problem 3 was use the equation method. So we have to look up from the equations what is find A given P. It's a pretty complicated equation here. So I, 1 plus I to the n in the numerator, denominator 1 plus I to the n power minus 1. So here I'm going to make a suggestion. Don't just do everything in your calculator without showing your work. You're going to be a lot less likely to make mistakes if you actually write the individual intermediate steps on your paper. Or if you do have mistakes, you're more likely to catch it if you write your intermediate steps. So you can see here, I start off by writing the equation. Then I write the substitutions that go into the equation. And then I write the numerator quantity, the denominator quantity, and then finally I calculate the factor. So, I mean, you could maybe get it right if you just put it in your calculator and then you get some factor, but you should always, especially in exams, double or triple check your work, and it's a lot easier to check your work if you've got these intermediate calculations on the page. So I'd really strongly encourage you that it's worth the couple of seconds it's going to take you to write the individual steps, including the formula, the substitutions, and the intermediate calculations. So in the end, we leave it as $3,095.82 because we can express all the precision we need. We're going to write it to the nearest penny for this example answer. So are there any questions on problem 3? All right. So just to revisit the announcements, I guess the thing you've got on your plate right now is homework number 2. And you could probably get a pretty good ways into that assignment. You'd make some nice solid progress on that if you started it now. It's due by 1 o'clock on Wednesday. So that's it for today. I'll see you in class on Friday.